both the assist and then you had another call that you also want to apply for.
Yeah.
Can you just elaborate a bit more? What was the assist project?
So the assist project was about mainly image-guided therapy. So radiotherapy is one type of image-guided therapy where you use medical images to decide how to use radiation to kill cancer cells.
Right.
So in the assist project had several different parts, but we mainly focused on brain tumors in relation to radiotherapy.
And then using AI to detect the tumors in different ways, or what was AI used for primarily? You would say?
Yeah, so in radiotherapy, there are several steps that take a lot of time for the doctors. So they have to draw the tumor, they have to draw different risk organs. So that can take several hours for one patient. And then from that, they have to generate a treatment plan,
right,
which can also take hours. But with AI and deep models, you can reduce that to maybe 5-10 minutes.
Yeah, so this is ultimately an augmentation boost that is very, very strong. So
empowerment, right?
Empowerment, augmentation. I mean, like the person
augmentation. You think sometimes in like data or AI augmentation. So I think that term can be a bit confusing.
Yeah. Okay. Fair enough. But it's like there is a workflow here that has some key points that are very substantial that we can support here.
Yeah, there is a clinical workflow with what we call segmentation and treatment planning.
Yeah.
And it can take several hours per patient.
So you guess you use semantic segmentation techniques then?
Yeah.
To do formally the kind of encirclement of the tumor or the area where the potential tumor exists.
Yeah, so the tumor that you want to kill with radiation and then the risk organs that you don't want to damage. So that becomes an interesting optimization problem. So how do we kill the tumor while not damaging other parts of the brain or whatever organ you're looking at?
Brilliant. And you also used AI for the treatment plan generation, or did you focus on?
Yeah, so you can do that with AI as well. So you can go from the segmentations to predict how much radiation should we apply in every part of the brain, for example.
Right.
And then from that you can generate a treatment plan that can actually be used by some machine like a gamma knife or a LINAC that will apply the radiation.
So if I understand it right here, that it's not as technical to you guys. It's like first we do AI in order to the optimization problem on the segmentation of cutting out the exactly right. And then you can understand and predict how much gamma ray should we shoot. And then you need to have a treatment plan. How will you space out that shooting the gamma rays, so to speak?
Yeah. So you can use AI in several steps there to save time in several steps. And you can also use AI to if we take it from the beginning, in radiotherapy, the traditional way is that you collect CT images, or basically 3D X-ray. But that requires radiation, which is bad for the patient. So now we are moving more and more to MRI, which does not require any radiation. But you sort of still need the CT to calculate the best radiation plan, because CT is sensitive for bone, and you can use it to calculate how the radiation will be reduced when it hits your bone, for example.
Interesting.
So you can also generate, instead of collecting the CT, you can generate synthetic CT from the MR images. So that's another step where you can use AI.
And all of a sudden now, things that takes hours to do manually, we are now finding ways how we do it algorithmically.
But not just time-wise then. It's also a health benefit, right? So you can use an MRI, which is less damaging to the patient. And then from that generate CT scans, which you then can use to have the proper treatment plan from that.
Yeah, so then you remove the radiation for the patient.
Interesting. But there was another angle here, and what we talked about this just before we started the pod. you're moving actually in a direction now where there've been steps of projects that leads into assist. And one of the key learnings that you sort of are addressing in the assist project was how do we create bigger data sets in a good way. So there is a piece here that we will talk about today a lot, the federated learning. So what was that piece in the assist project about collecting the data sets? Could you frame that?
Well, it's a common problem for basically all types of medical data. That if you want to do deep learning in AI, you usually have to have big data sets. But in medicine, that's usually difficult because you have to respect ethical rules, GDPR, and other regulations.
You can't just take all the data and then you stump it.
You cannot just call a hospital and get 10,000 images, which is probably good, but
could be.
So
cool. And I think this is a topic we will dig much deeper into very soon. But just to also talk a bit about the other point, you had another deadline today to submit some other application.
Yeah.
And can you just elaborate quickly on that? What was that application that you applied for?
Yeah, that's basically to continue the federated learning part of the assist project. So then we wrote an application to a call from something called WASP DDLS. So WASP is a program from Wallenberg Foundation, and DDLS is another program from the same foundation focusing on life science. So they wanted applications where between 3 to 5 researchers go together to create a nest that will achieve something bigger together. So we wrote an application with 5 persons from 5 Swedish universities in 5 different cities, so that we can continue this federation in 5 cities.
And then I assume Andreas Elander, or who was the guy, or Salman Tor, or who were you working on that he has a scale-out connection? Or
and Andreas and Mattias Åkesson. Also.
Okay. Well, I wish you the very best luck on that application. It's a super important field, and you have so many interesting parties and companies, and Linköping on the ride there as well. So congrats on that, and I hope you can relax a bit now. The day is over, and now you're here to speak on the podcast and just have a bit of fun.
Yeah, but how did you manage? Did you some friends? Because you were up here in Stockholm, and I guess people were working to get the report in and report out.
Yeah, I mean, I try to plan a lot ahead. Yeah. Which helps if you have to write these big applications. So for this application we submitted today, we needed, we ended up with 19 support letters. So that then you have to start at least a month ahead to ask for them because people are busy and.
I was going to say ChatGPT.
How much ChatGPT was used?
It cannot sign the letters, unfortunately. But
Well. I hope you got some use for ChatGPT as well in the writing process for the application.
But a big day, an exciting day.
Yeah.
Well, anyway, super welcome here, Anders Eklund. You're associate professor, right, at Linköping University, the best university in the world, I can say, coming from that place myself, a bit biased, but still, I think from an AI point of view, the best university. A lot of people would disagree with me.
You could have so much shit for that comment, by the way.
This is objective feeling, but it's a really good university, I think. Anyway, you focus on a lot of different things, but we're here to speak a bit more on federated learning and how we can work with data, privacy in machine learning field in different ways. So that will be super interesting to dig more into. But before that, can we just...
But just 1 second. The theme we said more interestingly, federated learning, specifically in the health or medical sector. Yeah. Because it opens up a lot of different challenges where federated machine learning and privacy comes in. I just wanted to add the medical part here. Yeah, that I think was quite important.
In medicine, there's lots of sensitive data.
Yeah. So I like that. So I just wanted to add that.
I think it's nice to be really concrete, as you say as well, to have a concrete field like medical field to speak about, and it makes it very obvious why we need this kind of privacy preserving data management in different ways.
Yeah.
But before that, perhaps Anders, could you just elaborate a bit more? Who is really Anders Eklund? How would you describe yourself?
Well, a person who likes to do research on. So I mainly develop methods for analyzing medical images.
Mm.
So, for example, my main background is in image processing, and then I've also done statistics for image data, and then the image processing field has become more and more machine learning.
Yeah.
So now it's like 90 or 95% machine learning.
Were you a bit, I mean, I know some other field or people that were in academic research and they, spent so much time doing like edge detection algorithms back and forth, non-deep learning based, and then they got completely side rails, by deep learning, and all the research they'd done gone to waste in some way. Was that something that happened to you as well, or?
A bit like that, but I mean, I try to see the positive side, that now I have a reason to learn about machine learning, and I think that many times you can take inspiration from old methods to make machine learning smarter and not just throw in data.
Oh, this is a topic, combining symbolic and machine learning, or understanding how we take the next step. We have so many different angles on this.
Don't say symbolic, I would say, but domain expertise at least.
Domain expertise, pins. We have the idea of physical informed neural networks. We have many ideas like that.
Yeah.
That where this sort of don't throw away the old. That's the bottom line.
Yeah. So I think I have one course in medical image analysis that starts in November every year,
right?
And I mean, from one perspective, I should transform that into a pure machine learning course. But from one perspective, I don't want to do that.
Okay, interesting.
Because I think it's important to first learn the older methods.
Right. Okay, cool.
Because there are tons of online courses on machine learning, but learning more traditional image processing, it's maybe not as easy.
But why would that be a benefit to understand that angle? Why is it relevant?
Well, I mean, it depends on the problem you're trying to solve, but sometimes you don't need machine learning. You can just use simpler methods or combination of simpler and more advanced methods.
So should I understand this a little bit like these fundamentals you need to get around image processing, even to be mastering how to apply machine learning? Yeah,
and maybe instead of just starting with machine learning, start with some simple method and see how well does that work.
I think this is an important topic. I got a question actually today from a person that were working with a project, and they come and asked, Anders, is it okay if I don't use machine learning for this one? I mean, I know that was the idea, but I think we can use simpler statistical methods. And is it okay if we do that? I was like, that's great. Don't apologize for that. If we can find a similar way to solve the problem, that's even better, right?
Well, we have Einstein's razor, Occam's razor. You use the.
I mean, it's strange how so many people just always use the sledgehammer, so to speak, for things that may not need it sometimes. And you should be really happy if you can find a way that can use simpler methods to solve the problem.
But I think
wouldn't you agree?
Yeah, but then Anders is onto something, because if we only teach the sledgehammer, if we you can use generative AI for everything, LLMs for everything. That's going to be costly.
I mean, especially generative AI. Everyone is just saying,
the sledgehammer
how is an LLM going to solve this? And I said, this has nothing to do with an LLM.
You could, but that's like going a big roundabout.
Weird.
We are on your side. We think you should continue doing that.
I mean, we have some parts that are deep learning,
of course,
but another aspect that this is sort of the last course that the students take before doing their master thesis, and in their master thesis, many do deep learning.
Yeah.
So then they will learn that part anyway. So then it's maybe better to focus on more traditional methods.
How did you get started into academia? How long ago? What was your initial kind of steps into the academia?
I started my PhD in 2008.
2008. Huh?
So
You're a young person.
I first worked like half a year as a consultant at the company, but it felt like I couldn't use everything or much of what I learned as a student. So then I applied for a PhD position, and I didn't know much about it, but I applied and then I got stuck.
What was the title in the end for the PhD thesis that you had?
I think it was computational medical image analysis with an application to, what was it, real-time fMRI non-parametric statistics or something.
Interesting. Great. And if you were to just elaborate a bit more, what's your current position at the university? What's your role and what do you work with mainly now?
Well, right now I try to find more money to hire new people.
So honest. So honest. I love it.
No, but I have a mix of teaching and research, and I'm also the director of graduate studies at our department. And I work at 2 departments. So the main department is the Department of Biomedical Engineering, which is located at the hospital. And then I also work at the Department of Computer Science, where it's more focused on statistics and machine learning.
Awesome.
Is one more applied and one more methods if you contrast where your work is going or what your focus is going?
Yeah, I mean, at the hospital I collaborate with several medical doctors, and then it's almost another language when you talk to them. You cannot really talk about gradient descent and ADAM optimization, but you have to talk more about the problem they're trying to solve. But at the other department, it's more on the theory and making new methods.
I have a joke for you. Imagine working with, on the same project, and one guy is speaking Latin and another guy is speaking Python. That's what you're doing.
Yeah. I mean, if you want to work with medical doctors as an engineer, you have to be prepared that it will take some time, maybe several years, before you really understand each other.
Yeah,
because it's.
He has medical parents. So
I have medical parents. I grew up with Latin as my, breakfast table.
Yeah.
But I think there's a profound truth in what you're talking about. When people are trying to build projects and we are trying to, in enterprise, typically IT tech roles is over here, business is over here, and then you're supposed to solve this ping pong. And you are now saying, and I've used this analogy, this joke, of course you will have, if you want to work with on cancer spotting in image, like old example, of course you have the research team with the Python speaking guy together with the Latin speaking guy in the same team. Don't even try this at home, kids, if you're not working together. And I think you said it right now, a couple of years for this lingo to emerge. So what happens if I go to enterprise and we are ping-ponging in projects and we are never really working together? It's futile. It will never work. Do you agree? I mean, this is a hardcore problem, I think.
Yeah, I think you have to work close together for...
Period.
Yeah.
Continuous.
But I think that the cool part is that we can learn from each other.
Yes.
So that they learn more and more engineering, and I learn more and more medicine. So I think it's interesting that you can learn something not by taking a course, but just working with someone who really knows that topic.
Yes.
That's much more...
So your skills as a machine learning expert grows by working in medicine, and medicine expertise grows by working in machine learning.
Yeah, in one way.
But this is so big topic, because I think the misunderstanding here is how this collaboration pattern works, that we can ping pong. And if you use the word, no, this is co-creation. So we are not ping-ponging between 2 disciplines. We are merging them and we are iterating together to create a new normal. So the new normal is in the middle of the Venn diagram of 2 different domains. It's intersectional innovation. And this to me is co-creation. So you need to learn them, they need to learn you. And the ping-ponging with two separate domains will not get to the same result. And I think a lot of mistakes are done in this area, if I go to enterprise as an example.
Yeah, but that's one reason why it's so important that our department is located at the hospital.
Exactly.
So we can easily go to them or they can come to us.
It's the right move, for sure.
Yeah.
Awesome. Should we move a bit more into the core topics and theme of the evening? And working in the medical field, of course, we have a lot of sensitive data, and we still want to apply machine learning techniques in different ways, and that entails that we need to have some kind of secure way of managing that data, and thus we enter into the field of federated learning. Perhaps we can start a discussion. How would you describe what federated learning is?
Basically, a way to, for example, train models with more data without having all the data in one place.
So the traditional approach is you basically collect all the data, put it in one place, put it in a training data set, and you can train the model from it. But now you don't need to merge all the data.
Yeah, you can have data in different hospitals or different cities, which makes it you don't have to send the data anywhere. That's the main advantage.
So could you phrase it that instead of sending data to one place, you send the models to where the data is?
Yeah, like if you want to find the best recipe of a certain cookie or a cake, and maybe you have bakers in 3 or 4 cities, and you know that the milk in one city is different from the milk in another city, and the eggs are a bit different. So, and you don't want to send around the milk and the eggs between the cities, but you can send around the recipe, which is much easier.
Yeah. So in practice, and I guess federated learning can be used for different use cases. One is for large hospitals, for example, as you were speaking about, but it could also be like small edge devices, like mobile phones or something that could be using it, like at the Google keyboard, for example, that can be learning how to predict the next word without having to send the data from each mobile phone into some kind of central place. Instead of training.
And you can maybe have it in every car for some. If there are applications where you need data from every car, or
so in short, move the model instead of moving the data.
Yeah,
and this is, I think this is a massive discussion. I grew up in the energy industry, so I first time I came across and met Andreas at University of Uppsala. I realized how big this is going to be in the energy industry, that we have our different distributing service operators, and we have a transmission service operator. At the one hand side, I was supposed to not share any data because it was NSI class. This is critical infrastructure in Vattenfall. But at the same time, I need to send some data in order to optimize the grids of the whole thing. Yeah? So here we have now a classical problem that we have many different competitors in one hand that should have their data and do their thing, and at the same time you need to share in order to optimize for the greater good. So there are so many examples like that if you start thinking about it. It's a massive problem where logically there is, why should different people in different companies send all their data to a central, there's so many angles in this.
Yeah, like I mean, in medicine, you can think of medical images, you can think of genetics, you can think of text in patient records, and so that there's many examples where you have sensitive data.
And the whole journal problem, we are trying to coordinate to have a perfect patient flow, and everybody thinks, why don't you just fix it? And then on the other hand, we have the ethical consideration of privacy and how do we share data and all that. Which is not an easy balancing act here. So to find techniques where you don't need to go beyond, you can have privacy preserving approaches. It makes total sense.
Yeah, but it's also, I mean, you also have to follow the Swedish law. So I'm not an expert on the legal aspects, but for research you can do basically whatever you want as long as you have ethical approval. But as I understand it, there are sort of other laws if you want to do it in clinical practice.
Exactly.
So if you manage to show in the research project that federated learning works, we can do many things. But I think that the Swedish law says something like that you cannot combine data from different hospital regions. So then it may not be so easy to use it in clinical practice.
And just to make it really simple and clear, I mean, we have this kind of cross-silo, cross-device type of federated learning. When you do traditional machine learning, you feed batches of data to a model, you calculate some kind of loss value, you get some kind of gradient that then used to update the parameters of a large model in some way. Now I guess instead of calculating this, the batch and the loss in a centralized place, you calculate the loss outside in the edge, in a university or some device, and then you update the model and just locally at that place, right?
Yeah, each node in the federation will do like one or a few batches of training, and then they will send an update to like a global server, which will combine the updates from all nodes, and then merge them somehow into a new model that will be sent out again, and then you iterate this, that you send the model back and forth all the time.
And that has some pros and cons, I guess. Pros, of course, is that you don't have to send the data and you have better privacy-preserving methods in this case. But I guess there are some cons as well, right? What's the drawbacks of using federated learning, you would say?
Well, it will be more. It can be more difficult if the data in every city or in every hospital is a bit different. If you have heterogeneous data, that maybe you have maybe the patients are older in one city compared to another, or maybe you use different scanners in every city to collect images, then the images will look different, so they have different statistics. So then there are ways that you can sort of harmonize the data, but then the challenge is to harmonize the data without sending any data around. So then you're sort of back to square one, that you want to make the images or the data more similar, but without sending it around.
But for me, that is not as technical as you guys. Is there a way you can help me sort of break this bigger problem down into the core patterns or the core problems we need to solve? I mean, like there are just okay, we want to have privacy preserving data. We want to send the model to the data. Okay, great, get that part. Read the memo. You know, how do you now break that down into a workable solution? What are the core patterns or capabilities that we are trying to solve here underneath the surface, so to speak?
To run a federation, or
as an example.
Well, you need like a computer in every city or every hospital.
Okay.
And then you can have a challenge that the hospital may not want to open the firewall.
Okay.
So either you need to have the computer outside the firewall, or you need someone to open the firewall for you.
So you have one problem here. One piece of the puzzle is to solve the compute at the site.
Yeah.
Okay.
And then you often, I mean, when we did federated trainings between cities, then I mean, I'm sure you can optimize this, but then we sort of needed all the persons to start their clients at the same time.
Oh, interesting.
And then the more nodes or cities you have, the harder it will be to synchronize that everyone can work at the same time.
So there's a coordination synchronization topic here somewhere.
Yeah, so there was a paper published 1 or 2 years ago where they did federated learning with 71 cities around the world. And then you start to have different time zones. So if you want to call someone in Japan, they may be asleep, or so then you have this logistics problem that you need everyone to start basically their clients at the same time.
Is this as a way to get the data into the training run in a good way? Or why do you need to do it? Why can't you do it as asynchronous?
Well, I guess you can do it in different ways, but at least you have to make sure that all the computers are up and running. So in the best case, you can control all the computers from one computer, and then you don't have this problem. But it can be a challenge if you run into small hurdles that you need to restart your computer or fix some small bug, or then several persons need to do something at the same time.
Okay, so some technical challenges and I guess security challenges there, because universities have really strong cybersecurity demands on them. It's not easy to get into their on-prem networks, and it's not easy to send something out of their on-prem networks, but you do need to share not the data but the models or the gradients in some way, and that in itself could be challenging, I guess. And then the coordination around that, But if we were to move to a question, how safe is it to share the model or the gradients in contrast to the data? Is it really not? Is there some kind of privacy or legal challenges with that?
Yeah, I would say that it depends on how much training data you have at each site, and it depends on how big is the model or how many trainable parameters.
Right.
Because the more parameters it has, the more likely is that it will just memorize your training data.
Yeah.
So that there are more papers coming out showing that you can, from the model, extract the training data.
Right.
So that's one topic that we want to cover in this application we submitted. So can we quantify data leakage? Can we quantify how much has a model memorized from the data?
And I guess model leakage in this some way. So can you extract the data from a model itself?
Yeah.
And if you can extract private or personally identifiable information, it also becomes a legal issue or challenge. In that case,
I think about one or 2 years ago there was an investigation by this Swedish EMI, or the Swedish Authority for Privacy Protection, where they looked into this.
Oh, really?
Because I think there was a project between Gothenburg and Halland where they did federated learning with tabular data. And then they wanted to investigate, can we do this in a clinical practice? And then this EMI investigated this. And I think that they came to the conclusion that you can never be 100% sure that there's no data leakage. So then the machine learning model itself can be seen as personal information.
Right.
So they had a rather
strict,
rather strict view of this, which I think is too strict.
Because it's the same. If you have this super strict view, it will tie down anything in the end, right?
Yeah.
Then you can't do anything.
You can't do anything.
Yeah.
But maybe can we go a little bit more understanding on the patterns? Because we've talked now about the edge patterns of collecting data. You know, what is happening on the other side? What is the difference figuring out how to build a model that is working monolithically versus distributed or something like that? What are the core problems here? Do we have a summary on that?
Can you give an example? Or
I was just elaborating that, you know, when you build a model and you're working with one training data set and it's all in here and everything is super easy because the data set is clear. Now, if I'm gonna I have a central model, I'm gonna send the model out. I'm gonna collect that back. There's some extra mechanisms here that you kind of don't need to do when you do a monolithic approach on this.
Yeah.
So I just wanted to elaborate, what are those mechanisms? What are those patterns that sort of make something work distributed on the hub side?
Yeah, well, one thing is that you need to define how you should merge all the models.
Good one.
So the easiest is just to take the average. Like if you have a model with 1 million weights, then for each weight, just take the average over all models. But that's very simple. Because if maybe you have one node with 1,000 data points and maybe one node with 25 data points. So then it's very unbalanced.
Exactly.
So then you need to put weights on a higher weight on the big node and a lower weight on the smaller node.
So what we're talking about here is like we're talking about different kinds of biases or different kinds of balancing. So when we're working distributed, now we have the thing is, okay, we're going to put this together now, and it should be as truthful as possible.
Yeah. So I mean, federated learning solves the big problem of data sharing, but it will create another problem, other problems that we need to solve. And then, as I mentioned, we have heterogeneous data that they may look different, so that a model that you train in one city may work well for that city, but a local model trained in another city will work well for that city. So if you take the average, you may get something that doesn't work anywhere. Because your data are too different.
Yeah, but this is exactly what I was trying to go for. So when we go distributed, what are the key problems underneath here? So you highlighted now getting the data in from all the different places, the heterogeneity problem, the balancing problem. Yeah. So there are 3 or 4 fundamental topics that sort of pops up. We're getting benefits over here, but federated machine learning means we are solving this stuff.
Yeah, and if you have lots of data in one place, and not so much data in another place. And let's assume that you have the same hardware in every city. It means that the training will take much longer. And it means that in the other city, you train for maybe 1 minute, and then you're just waiting for the other city to finish. So then it becomes more inefficient because all the nodes have to wait for each other. So then you can, for example, randomly say that, okay, we skip the city for a few rounds, so we do more training here, just to reduce the waiting time.
Yeah, so the interesting thing is like going distributed, going federated has a no-brainer. This is stuff we need to solve, but it's not something that is easy. But it sort of when you fix that, you now need to take care of this.
Yeah, you get other problems.
Yeah,
but that's good for me as an engineer because then I have a job to do.
Yeah, but I think also I'm not saying this is bad. It's just about what is the engineering that goes on here, and this is not. I mean, like so we have like example like Scale Out, right? That builds technologies and platform about this exactly because of these problems. Because when you open up this can of worms, there are things that need to be solved, and that they are not solved in the typical monolithic architecture from the vendors.
You call yourself an engineer, by the way. Do you consider yourself mainly an engineer or a scientist?
I guess a mix, but I mean, I suppose most engineers they like to solve problems.
Do you have a preferred definition of what science and engineering is? And differences between them? I have some, but it would be fun to hear yours.
Not from the top of my head, no. But
well, we had this conversation a couple of times. What is the difference? It's a very nice angle, actually.
I can tell you mine and see what you think about it. And I think there is a lot of overlap between the two, but there is a clear distinction in the purpose, I would say. So the purpose for science is to build new knowledge that we have, and then you can share the knowledge in papers or in prototypes or in other ways. But the purpose for engineering is to provide value or build a product in a way. So then, to build a product or to provide user value in some way, you need to have knowledge, you need to have science. So you use science to be able to build the products and the value that you want to provide, but the purpose is very different. And when you do science, you need to have some engineering. You need to build like a prototype. You need to build up experiments. You need to build stuff to be able to come up with a new knowledge. But then you do what you need to do from an engineering point of view to, prove and build the new knowledge. Versus in engineering, you use the knowledge you need to be able to provide the value from a product point of view. Would you say that's a fair description?
Yeah, I would agree. Yeah.
But and then it's the classical conversation then difference between applied research or engineering based research. If I take Google or Elon Musk and SpaceX, who is sort of a strong engineering culture, but of course they need to now do research, or they are figuring things out no one has done before. So is that research? Someone would, is that research or is it not research?
I guess it's some kind of applied research, but there are many types of research. You can do pure theory, or you can do pure studies where you just collect data and look at the statistics. So it's
it's a spectrum, right?
Yeah, but it was this funny beef between Jan LeCun and Elon Musk. I don't know if you follow this, but this was such I think Jan LeCun went a little bit like snobby in terms of it's not research if you're not published, and Elon more or less said, get fucked. We're doing cool stuff.
Yeah, I saw some discussions about this. They have some, I think they call it Neuralink or something, that they claim that they can put electrodes or wires in your brain.
They actually have that done that on a human now. So
yeah, but I mean that's a whole research field of its own, and to claim that you are better than all researchers in the world on that topic, it's a bit arrogant. And
it is.
That might be true, but are they doing research? Are Neuralink doing research? Or are they doing, because they have clearly a product. This is the point, right? They have an engineering product idea. They want to build something, right?
Yeah.
But they are doing it something on such a bleeding edge. So they are sort of competing with the best research institutes on understanding how to do this. And I think this is very interesting, especially in the field of AI. Who is the bleeding edge on research in AI?
I mean, I suppose they're doing research in one way, but if they never publish it, as you say,
exactly,
then no one else can know exactly what they did, or they cannot continue the work. So from that perspective, it's not research.
I think you nailed it with that comment, right? Because this is how I can understand it also. There's one is in the pursuit of knowledge, and one is in pursuit of product superiority, so to say. And hence, of course, you're both doing research, but one is science, one is not. Maybe that's the way.
Yeah, but I think you can still do science without publishing it.
Yeah, can
publicly.
you? But can you call it science? I think that's a fair question.
I think you can have like inside an organization, like a pure industrial like tech company. Yeah. They can conduct research. They publish it perhaps only to themselves, not to the research community. It's still building knowledge, and the people doing that, internally, like some companies starting with A. Then they are, I would say, working with science, but they are not sharing it. And it's still like the purpose is still to build knowledge, but it's not shared.
Yeah, but we get into a semantic war here, definitions and all that. But I think it's quite interesting.
It is.
I attended this big NeurIPS conference last year.
Ooh. Yeah. Oh, you went there.
Nice. Yeah, cool. and then they had this sort of discussion where I think persons from OpenAI were part of the panel, but in several occasions they said we cannot say how we did it, and then some in the audience started to complain. Yeah, but this is an academic conference. You cannot say we cannot say what we did. Yeah,
I mean that's a good question. Is OpenAI, which is not very open, actually conducting science or engineering? And if they are not open with it, they're at least not doing academic research. I think we can all agree on that.
I think there's clearly then we need to start doing definitions in a spectrum. That we have the hardcore, the pursuit of science is the pursuit of knowledge, has to be shared. Otherwise, I could not agree with that this is sort of science. It is not to me. And then you have the full other spectrum where you have sort of product development, super proprietary. And then we have a grayscale in between, right? But there's a standpoint to me that goes all the way to this spectrum and all the way to that spectrum. I'm not saying we shouldn't have this stuff in the gray zone, but I kind of think you need to be more nuanced on how you discuss this then.
But I think also the same question about sharing or not can be applied to engineering.
Yeah.
So true. You can have engineering that is not shared at all. It's still engineering. But then you have the full open source movement, which is also engineering, but it's heavily shared. I think both are engineering.
Awesome.
And you can, I would argue, do the same kind of argument for science. You can conduct science that is shared or not shared, and you can conduct engineering that is shared or not shared. It's just another dimension.
Okay, so then we have another definition of open versus closed research, or open versus closed science.
Yeah, I mean, I think that the research field in general is going more and more to open science, because
I would hope so, but is it really?
Well, it's not very fast, but I would say slowly, because for example, the funding agencies are demanding more that you publish open access and that you will share your data. So it's slowly. Yeah.
But still, if you, this is a very interesting topic, and I can't.
We've been going down a rabbit hole now, so I'm fine with that, by the way. But
but you know, if you then argue that more and more of the big tech companies are driving research or science, and perhaps universities and academia is not to the same extent, at least anymore. If you go to NeurIPS, you know, it's easy to calculate the number of papers coming from universities versus companies, and I think we can see a very strong trend moving more towards, you know, tech companies. And then you can question, you know, okay, Google at least is very good at publishing and being open, so I think they are at least trying to be open. Some other companies, I won't name the negative one. I've probably said it so many times already, so you know what I think there. But
this is an after-work topic we will take with Anders. Yes. We're gonna make you make a list together with us.
In short, you know, I wish we could have more academic research. I feel really bad about that the academic research is not having the power that it once had. And you know, if you take funding, there is no comparison, I would even say. If you take funding coming from, you know, tech companies and how they can fund their own research compared to universities, especially in the field of AI and the LLMs and the large foundational models, no university can, you know, build foundational models anymore. Right?
Now it's extremely hard for a single researcher to compete with OpenAI or But there are, I think, more and more open language models like this Mistral or what it's called.
Yeah.
So and in Sweden we have this Berzelius cluster that anyone can use.
But it's like 1,000 GPUs, and then you have XAI that just released 100,000 H100. It's 3 orders of magnitude larger. Yeah. The same with Meta, Microsoft, and Google. They all have like 1,000 times Berzelius playing with.
No, so, I don't think we can compete in terms of hardware but we can
money.
But we can maybe compete with using smarter methods or smarter models or potentially. But,
and I think also potentially more unbiased research questions. So it's not driven by monetary gains to the same extent as the companies are. So I think it's super important for universities to be successful. And I wish we could have more efforts helping academia to be more powerful. But I think the trend is going in the opposite direction, unfortunately.
Well, I think that this WASP program, that they are donating a lot of money. So that's...
WASP is I think it's something unique to some degree in this.
So that context really helps Sweden.
Yeah, sure.
But it's also a bit sad that private family has to do it.
Yes.
Yeah, it's an interesting statistic when you look at the funding from WASP compared to on the other side.
We're having an oil fund in Norway driving so much research as well. It's also kind of strange. I wish we could have the governments really stepping up here and helping academia.
I think they have decided to increase the funding for research the coming years. But at the same time, they haven't adjusted for inflation in 10, 15 years.
So we're going back to normal.
Well...
Should we go back? I mean, like I was thinking a little bit, you know, if we're spinning on this research topic, and now you're going into this call that you applied for with WASP. What is the research angle, or what is the things that you really want to explore?
What's the research questions in the application?
In the application, exactly.
Yes. Well, it's similar to what we discussed, but what one
just restate it so we know.
One question is how do you merge the models in the best way? What is and you can call that aggregation function. So what are the best aggregation function for different models, for different heterogeneous data.
Exactly what we talked about before.
Yeah.
So this is now the aggregation function pattern we are talking about. Fantastic.
So that's one aim. Another aim is how can we harmonize the data, or for example, it can be images or genetics or text, or how can we harmonize the data so it's more similar?
So normalize them in some way, or regularize them in some way, or what do you mean with harmonize?
Maybe one city has an older MR scanner, so maybe the images have lower quality or lower resolution.
And then perhaps different age groups, as you said, or different demographics, or different hardware devices.
Yeah, and if you work with text data, maybe there are different languages. So then maybe one word will not mean exactly the same thing, even if you translate it.
Well, it can be worse than that. Different hospitals have slightly different ontologies or definitions of things in their journals.
Yeah.
I mean, this is not perfect.
Yeah, and in radiotherapy, there are different clinical guidelines in different hospitals.
This is my point.
Yeah.
This gives different ontologies for sure.
Yeah. So to make the federation work better, you need to harmonize the data to make it as similar as possible. But then the challenge is to do that without sending any data around.
Tough.
So that's sort of...
I've just been trying to wrap my head around the fundamental topic of bias and what happens with bias as a problem in federated scenarios. Could we elaborate a little bit on the fundamental topic of bias? We've heard about it, we've talked about it. How do we need to think about that in a federated context?
Good question.
And just to elaborate a bit more, I mean, biases in itself is an essential and really important.
It's a feature, not the bug.
So I think we need to differentiate between good and bad biases, so to speak. So some biases are good. It helps us tell if it's a bad or a malignant or a benign tumor, for example. Other biases, perhaps based on age or whatnot, or race or whatever, perhaps should not be used to try to do these kind of predictions. So I guess,
but if the age is a bias topic that's relevant to understand,
it was a bad example.
This is a perfect example, right?
No, it's super hard.
That we want to understand that blacks are getting more cancer. If that's the truth, if that's the reality.
That's very true. Bad example from me, but yeah.
But bias is difficult.
It is
really
right.
difficult.
So if you say that we want to harmonize the data, and I guess from a hardware device quality kind of point of view, it's easier to understand. We want to have, the data looking similar independently of the MRI scanner that you have or whatnot. But when it comes to like demographics, perhaps it's harder, right?
Yeah, I guess it's not really possible to change the age of patients and similar things,
but I guess you could normally, if you just keep the data locally to a hospital and say we want to average it out so it's always on age 30, and then if you have some global pattern saying this is the way you normalize it so it looks like a 30-year-old, perhaps you could do it in some way.
But you don't go that way.
Yeah.
You wouldn't go that way. That's a stupid example. That's what
probably. But I guess you could try to. I mean, you don't have to share the data necessarily to potentially normalize it against certain dimensions.
I have a super hard time wrapping my head around bias in relation to disputed approaches, or if what's the implication of that. I think it's I don't understand. I haven't thought about that myself.
Well, I mean, how to evaluate federated models, that's sort of a story of its own.
Yeah.
But I mean, you can either have a validation data set in every city, or you can have a separate city that was not part of the training at all. So how to evaluate the global model is not obvious. So you can do it in so many ways.
But I mean, do you think it would be okay to, for example, just share the distribution of different parameters like demographics or the hardware device used. And then if you send that and share that, perhaps that's still keeping privacy safe to some extent.
Yeah, I suppose that you could, instead of only using the image data, you can maybe fuse it with the demographics like age and sex.
But one way of looking at the same problem is like, is there a fundamental difference in understanding and working and managing bias in a more monolithic solution versus a distributed solution, or is it the fundamental same problems, or is new problems arising? This is maybe the core question.
I have not thought so much about it, but
it's an interesting. This is one of those things where people someone will argue around these topics without having a clue, right, on top level, right? Maybe it's the same fundamental process.
I think it's the same fundamental problem, but it may be harder to measure it.
That's the point.
Because there are so many other things that differ.
That creates noise in this sense.
That would be my first guess. But,
interesting.
Okay, so to just summarize the topic a bit here and trying to understand what the main research questions are in new application.
Thank you.
Partly is, we need to merge the application or the model somehow and do these kind of aggregate functions in a as efficient way as possible. You also need to harmonize the data, as you say, in different ways to make it independent of what the potential bad biases are in each site that you have, or silo, as I call it. Is that the main one, or is that the main
then we have one aim about data privacy and data leakage. Do we want to quantify data leakage and memorization?
So you want to continue on that? What someone else said? You mentioned a paper. You mentioned a topic someone had to try to look at leakage in a different context. Halland, Gothenburg case.
There are more and more papers on, for example, diffusion models that show that, for example, diffusion models that can create synthetic images, and we found the same problem ourselves, that instead of generating new images, it will just generate images from the training set. And that's not really what you want.
Could you elaborate? I didn't follow that.
Yeah, if you so a diffusion model is kind of generative model that can learn to generate, for example, new images. So if you train it with, say, 10,000 real images, it can learn to generate new images that look similar or come from the same distribution of images. But several papers have shown that it's sometimes likely that it will not generate new images. It will just take one of the training images and make a copy, and then you have not reached the goal of generating new images. Then you're just making copies of your sensitive data.
And do we need to make a small comment on the difference between transformer models and diffusion models here? Because as a layman understand, with diffusion models it's quite different techniques. You're introducing noise and then you're going backwards, or I don't know.
Diffusion models can use transformers as well.
So.
Transformer is more about the architecture.
Okay.
So you can have a diffusion model using what we call convolutional layers, where you do something called convolution, or you can do diffusion models with transformer architecture.
Okay.
So it's
so I'm mixing it up here as a layman. Please help me. Please save me.
I mean, it's two different things, but I remember speaking to Scale Out and Andreas there for a while, and I don't remember exactly the wording he used, but in terms of keeping the data safe and data privacy, as you mentioned, you can think of techniques going into the model. You can do stuff like differential privacy, for example, like trying to add noise to the data to remove potential PII or personally identifiable information to it, and homomorphic encryption and whatnot. So there are different ways to do it when getting to the model in, so to speak, the inflow of data to the model. But then you can also think potentially data privacy model out. So that means basically that the predictions you're making from the model could potentially leak the data you have. I remember some kind of article trying to see if they can from GPT-4 see some kind of text paragraph that was included or not, and they could actually extract to a rather high degree this exact quotes that's been used in training for it, so they can extract from the model the data it has received, and that's both bad from a privacy point of view. Is this? I guess these are some kind of research questions that could be interesting to look into as well, right?
Yeah, I mean, we propose that we want to take our trained networks and see if we can reconstruct the images that were used to train it.
So you're really hardcore trying to see if you can get the leakage proven hardcore, see the image.
Yeah, and so that you can quantify how close is that to a real image from a patient, so you can get some hard numbers on.
That's a valid question. Yeah, that's a good question.
Yeah. So is that fair to call it model leakage in some way, or what would we call that?
I'm not sure what the proper name is. But
you need to figure that out, and you need to put a paper out at NeurIPS.
Can we just move to the synthetic data kind of question a bit here, and let me, as a non-expert in medical field, just ask a perhaps stupid question, but synthetic data is used more and more, I would say, for also LLM training and foundational model training. And some people claim, we have no more data to train on. I think it's rubbish anyway. But anyway, you can see that, potentially it will come a point where we're starting to get a lack of data to train these kind of super large foundational models on. And now we have this kind of O1 model that is using potentially techniques, even though we don't know it by heart because they're not very open in OpenAI. We can guess that they're using this kind of star or self-taught reasoning kind of approach, similar to AlphaZero, right? Yes. AlphaZero was this technique back in the day in 2015-16 where they trained a model to play chess or Go without using any human data at all. So all was synthetic data. It basically played itself. So it generated its own data and tried to, by having some kind of game, see if it was good or bad. And some people now claim, this is actually what O1 is doing in some way. So they're generating data in that way, improving the model all the time. Do you think there will be similar kind of ways for, let's just take semantic segmentation. Can you generate images to make the model improve itself without even using, real human data for it?
Maybe.
It's a hard question.
Well, we have published one paper where we show that you can train a segmentation network with only synthetic images. But without any human data at all, I'm not sure.
Perhaps you have some kind of GAN approach, where you have some kind of detector and generator and it tries to fool itself in some way.
Yeah, I mean, we managed to show that we can generate realistic images and segmentation itself at the same time. And then we can use that to train a segmentation network.
But have you read the article or paper on, I can't remember if they call it degradation or like what happens when we run out of human produced data, and ultimately it's only training on synthetic data, and ultimately there was a paper published in a couple of months back or 1 month back where they were arguing that in the end we will lose any quality.
I mean, it can be mode collapse in the end.
It was a quite dystopian paper.
Yeah, but there are examples where they do the opposite. So they actually, gain above human performance
with the synthetic data.
I just remember, one project we did in Peltarian time with Elekta actually, and we had this problem where the ground truth, the label data for segmentation in this case, for actually brain tumors, were made by humans. But humans were inconsistent with themselves. So even expert radiologists, they had only like 85% consistency or something. So we knew the accuracy was bad because humans are bad. And then we had a model that could come up to 85% accuracy, but how can you even go above 85% when the training data itself has so much error in it?
That's another aim of our project.
Oh,
really?
That's a good one. Explain.
No, but that's a challenge in radiotherapy, that since there are different clinical guidelines that say exactly how you should draw the tumor, the data will be different from different cities.
For sure.
So then we have proposed 2 ways that can potentially solve that. So
that's super interesting.
So one way is to include like uncertainty in the model, so that you, for example, say that you should be very certain at the center of every segmentation, but you should be uncertain at the border.
Ooh, cool.
Or for example, that you can maybe, if you have a segmentation network with maybe 5 layers, you could maybe train the first 2 layers in the federation, but the deeper layers you maybe only train locally or something.
Interesting.
Oh, this is so interesting how you need to become more nuanced. And you need to figure out how you do it on the certain where this is everybody's doing the same, but the longer further out you get, this is more uncertainty, and you need to have localized.
Well, we don't know if it will work, but that's what we.
But the research question is super interesting.
Yeah.
Cool. So we have this.
It's time for AI News, brought to you by AIAW Podcast.
We have this small break. I'm not sure if we told you, Anders, but in the middle of the podcast, we take a small break and just speak about some of the recent news that we had, and each one of us can, bring up a favorite research article that we want to speak about, or a news article in some way. Let me ask you, Anders, do you have something that you would like to speak about? Something you read about recently? That's interesting?
I recently read about a news article, and it's actually about medical data.
About what? Medical data?
Yeah, so it's about transcribing conversations between doctors and patients. And that, I've never worked as a doctor myself, so I cannot say how much time it takes, but I guess it's something they have to spend a lot of time on writing down the main points of this conversation. So there are apparently now software you can buy that will do this automatically.
The Whisper model from OpenAI is amazing in this transcribing audio to text. It's amazing.
But the problem that was mentioned here is that Whisper will sometimes hallucinate.
Yeah, of course.
So it can add parts that were never said in the conversation.
Oh, okay. So the article was about that. Interesting.
So it can, for example, add that someone was violent, or it could add a racist comment. Or
That's hallucinating full on.
Yeah.
Wow.
So then it got me. I got very confused, because normally, if you want to use software in a clinical setting, you have to go through many steps of validation to get it approved.
Yeah.
And according to this news article, it sounded like it should be easy to. It should not be possible to get it approved if it hallucinates.
Yeah, right.
So either they have not done a proper validation, or they're using a software not clinically approved, which is also strange.
Yeah, that sounds super strange. I mean, it's a very interesting topic, I think, and I guess also it sounds strange. I was trying to find an angle against what you said, but I can't really do it. It's very true what you said. How can you not at least evaluate the amount of hallucination, or have some procedure that protects against it somehow?
Then how can you, as you said, put it into clinical application? How can you? You can't.
Yeah.
I don't think.
And it also said that when it has transcribed the audio, it will delete the audio.
Oh.
So you cannot even check.
Oh, that's even worse.
But then I read that this Nabla company commented that we haven't seen a lot of hallucination.
Mm-hmm.
So then I'm not sure what to believe.
But it sort of puts the finger on that we have so much opportunity to do things that augments our workflows, but we kind of need to do in AI innovation and AI safety by design at the same time. I came to that conclusion in other angles, that AI innovation and AI safety you need to do it by design. You need to think the right way from the beginning. Yeah. Otherwise, there is so much blast radius in all this stuff.
Yeah, there are several persons that complain that United States, they innovate and European Union regulate. But here it seems like we should have more regulation if they use this hallucinating model in the hospital.
I think the fundamental argument is, can we find a path where AI safety and AI innovation converge? So the whole sort of bipolar understanding of this is wrong. So what is the middle ground that is the right way? Which I don't know what, but for me, the bipolarism in this argument is wrong.
Yeah.
Both extremes are bad.
Yeah, you need to think of it from the start. And
so for me, this becomes by design. How do I design my process? Yeah. How do I design my research? How do I design my product development? As a way so I balance or iterate between these perspectives. Yeah. Because if you do innovation as an afterthought, you're fucked. And if you do regulation as an afterthought, you're also fucked. In my opinion, it's that simple. Sorry for my language. But it's so obvious, but no one gets it right, in my opinion.
But it's a hard problem, though.
No, I don't think it's a hard. It's by design, balancing,
but
iterating.
No one has figured it out in a good way.
Yeah, but iterating between two extremes, it's a two-hat problem. You need to wear two hats. You need to flip hats iteratively. Yeah. Well, I don't think it's that hard. I think it's more political.
If no one has found a solution for it, then it's probably kind of hard.
No, theoretically not hard. Politically, organizational people, practically hard.
Engineering-wise, probably hard.
Engineering-wise, yeah. So practically hard. In theory, if you have the right steering on this, I don't think it's that hard.
I think it's hard, but it's an important one.
It's an important one.
Do you have one, Henrik?
I have an angle now. I have 3 different articles that I find. I've just found a new cool guy, Ryan Dawes. He's one of those tech editors or tech writers, and he's doing a pretty good job of just doing nice snippets of AI news. So shout out to Ryan Dawes. And I find the one I want to lead on is, I think, a very interesting one, just for people to know about. So the Open Source Initiative, OSI, has unveiled a definition framework to evaluate whether AI systems can be classified as open source. So the announcement of the first open source AI definition, OSAID. So it's the whole thing about, we have had the conversation about, we need to go open source on models, but what is open source and who is open source? It's a minefield, right? What is really open source? And I found that very refreshing that someone is trying now within the OSI framework. Has been around quite a long time, I think, to support these topics, to understand open source community. So they have a definition that I find is quite interesting. So an open source AI system must be made available under terms that grant 4 essential freedoms. Use the system for any purpose and without having to ask permission. Study how the system works and inspect its components. Modify the system for any purpose, including change its output, and share the system for others to use with or without modifications for any purpose. So it's a quite concrete, trying to take the open source ideas from software and how would we apply it to AI. And if you follow that definition, as that is truly open source, I don't think it's that many.
Yeah, very few.
Very few of the models would actually would be labeled open source so we get to the point, once again, it's a spectrum, right? Yeah. But I just found that
But it's interesting how it works. It's even a part of GDPR. You have to be transparent how the model works if you want to use an AI model in that. And it's kind of funny. How do you do that for a deep learning model? You can say that here are the parameters. It's just a mathematical procedure. Here is how it works. Is that sufficient? Who knows?
But my point with bringing up that particular piece of news is that there are this is a big topic, I think, in terms of understanding that. And I think even in this room, we have swayed back and forth. Or large language models, all that thing, we should really try to make it open source. And then we realize, oh my God, how powerful they are. Can they be open source?
I think, with this definition, fewer and fewer of the foundation models are getting open source, for sure.
I'm not even sure the meta ones would fall into that category. I don't think so.
Maybe.
Interesting, right? So that was one. I had a couple of other ones. I can do one more if you have the time. The other one, this one I thought was fine. Same guy. MIT breakthrough could transform robot training. So in MIT researchers, this was sort of, the news was, I don't know when the paper was out, but the news flash is from the 29th, is new. So they have figured out a way how we can improve and develop robot training methods that reduces the time and costs while improving adaptability. So the core problem when you're training robots, when you're trying, is that it's always done very specifically. So they are trying to find a generic approach where you can get data from any kind, and in this way then structure it so you can use it for training robots. So the approach is called heterogeneous pre-trained transformers, HPT. And it combines a vast amount of diverse data from multiple sources into a unified system, effectively creating a shared language that generate AI models, the generative AI models can process. So it's some way in sort of using generative AI, using the large language models techniques as a way to sort of simplify finding the specific training data set for a specific robot application. I just found it interesting. So if you think about what are the different research angles, how do we truly progress? So, how to get the cognitive AI with the physical, so to speak. And then this, I guess, is a big hurdle, how you train the physical robots. And now they think they have made a breakthrough on how to think about that. I found that interesting.
Yeah, I've read that Jan LeCun keeps using this example that LLMs cannot reason, that it cannot understand basic physics. I don't know if that is correct, but he keeps using this as a counterexample of that LLMs can reason. Because if they would understand physics, they would know what happened if you push an object or...
Yeah.
And I think what he's saying, I follow Jan LeCun so much, but at least if they only have textual data, how much can you really infer in terms of gravity or physical laws that we otherwise have? You can get some part from text, but unless you have visual data or multimodal data, some parts will not be captured. But I think, some other people have said that even the concept of colors, which seems hard to get by simply looking at text, seems to be captured still by, purely LLMs that only see text, that seem to have some understanding of what colors are, which is kind of interesting. But of course, some concept will be super hard to capture without having image data to combine with textual data, I think.
Yeah, we can stop there. But there were two interesting pieces.
Yeah. I have a few because I think that we have missed some of the most important that happened last week. So I'm going to be just very quick about it. First of all, Denmark became like an AI superpower.
Yeah, this is a good
right,
one.
Because they got their own Jeffron.
Yeah,
Jeffron, huh?
Something like that.
Jeffion it was. Jeffion supercomputer. So Jensen was there, and they promoted actually the launch of the AI supercomputer in Denmark together with the prince or king.
No, right? the Danish king was joking. I guess there's two kings in the room. Yeah.
Right. and
that's very true, though.
So I found that a refreshing comment by a monarch. I guess it's so cool.
That's very cool. As you know, my news are always about usability and stocks and everything else. So. The first thing, it was the negative one. You remember there was this accident last week where one kid in the US, I believe, committed suicide by just basically talking with a chatbot from a company called Character Technology. So they have like this AI chatbot that you can actually talk with. It's very popular amongst children, and it's basically giving them comfort and etc. So it came to that point that the chat was basically very, very emotional and providing some sexualized conversation and encourage suicidal thoughts, and then the kid basically killed himself.
It's terrible.
So now the mother is basically suing them, and probably she will win, because now when they're looking at the chatbot and how it's built and etc., it's actually very addictive, as they say, and it exploits children, leading to an emotional abusive relationship, it says, right? Third one, you remember that LinkedIn, there was a big bomb like that LinkedIn basically just enabled collections of your data without even noticing you, and Casey Kozirkov and many others.
It was a massive outroar from the people who understood it.
Good thing is that we in Europe, we were protected from that, so we didn't.
That was only in America, yes.
Yeah, exactly, America. So now it came basically why they were doing it. So they are right now releasing AI agent, which is basically going to help recruiters to select candidates, and then also help them target the LinkedIn users as effective as possible, matching them with their criteria and everything else. So now they are making a proper business out of it. And LinkedIn for a long time has been actually making a lot of money from the recruitment side. It has been their strong side in the capitalization of the entire product, which I think is super good.
Yeah.
Then I will leave this for the next time, which is basically IBM Granite 3.0, right? Because I will leave this to Anders to explain this for the next one. And the last one that I think is very interesting is this one. Is basically a cost of sleeping on AI, which many people are still not believing that this is not it, and it's not a big thing. This is what happens with companies that are super big and they are basically late on the AI journey. So Samsung loses 1/3 of its value in 4 months. Basically 122 billion of the market value was erased since its peaks in July 9. And this is actually expected because they were very late. We are talking about the semiconductor part of Samsung and not basically the phones and etc., right? So it's sad to say, so this is basically explain everything. We know that NVIDIA is on the top of the game when it comes to chips, and we know that Apple and TMC are gaining quite a lot of traction in that, and TMCU alone has added over 330 billion in the market value this year. While, Samsung has been lagging behind it, and you see what has happened. 1/3 of the entire value deleted just in a matter of months.
It is a very interesting one, and you can see basically, of course, TSMC is a leader in this with 90+% of the advanced chip market, but you can also see all the tech giants now producing their own chips.
Yeah.
And Samsung is not doing it.
Yes.
So it's possible to compete with NVIDIA and TSMC, but Samsung has failed.
Yes, has failed. Actually, has not been on time on this.
And then sleeping on it.
Yes, sleeping on it costs. And that is basically now even we know what is the KPIs of sleeping on AI.
Can you extrapolate on that, sleeping on it, from the chip market and this context? Can you extrapolate all the way out to using AI, in enterprise and all that? Can this sort of be? Can we see this as okay? This is sort of giving a trend, a signal, a trajectory. That if you are, this is what happening further back or upstream. So if you go downstream and we are now becoming software companies or becoming enterprises and we are sleeping on it, will we have the same sleeping on the AI effect all the way down the downstream? I think so.
I will let you discuss this, but I think there is like it's a palette of how much is going to affect you.
Yeah, true.
It's great because if you look, Samsung, their core business is semiconductors, which means losing on this is 1/3 of it. But for example, for Scania or Ericsson's and etc., that
indirect, maybe
it's a little bit indirect because it's hidden inside of the optimization of their processes and customer service, maybe, and some other things. Right?
But my argument is, it's because it's indirect, it's a lagging effect, but the effect is the same.
Yes, exactly. Yeah. Right. So we'll see.
The statement saying, the AI won't replace humans or companies, but AI. Or companies that use and people that use AI will replace companies and people that don't use AI. And that's certainly true for Samsung, and I think it's true for most companies. It's just a matter of time before it happens in some way.
Well, Jeffrey Hinton claimed that, I think 7 or 8 years ago, that medical doctors who look at images would be replaced by AI, and it has not happened.
I think that's a wrong way to see it. I think it empowers people. And radiologists and other people that use AI will be the one that
they can work more efficiently, but I don't think we should replace them.
No.
But look at the doctors today. They're spending maybe 1/3 of their time basically just going through the journals of what they have done today, and they need to basically record that, and that goes to a repository system. Then somebody's typing that and everything else, right? So if they basically utilize this time to actually save lives, rather than actually doing, memorizing what has happened in each second of their daily work, only that is actually beneficial, right? So in that case, there are more people will have opportunity to focus more on what is their core business rather than actually doing the admin stuff and everything around it. So,
you've already taken so much time. I had a big topic that I want to bring up, so now I have to really compress it into like a few minutes here, which I think will be really hard.
Go for it. I don't care.
Okay, so one big release in last week was Claude.ai, Anthropic. They released a new version of the 3.5 Sonnet and the Haiku. Sonnet is the mid-size, Haiku is a small-size model that they have. So the new version basically beats GPT-4o on especially coding tasks to a large extent. So it's surprisingly good, but that's not the big news. The big news, I would say, is that Claude and Anthropic have released what they call computer use.
Yes, that's one. I saw that one.
And I think this is more profound than people think. This is almost like a Terminator, Skynet kind of moment.
This is the agent story.
It is.
Yeah, it is. Now we get this happening now.
It's a meta-agent story.
Yeah, for sure.
So in short, what they have done is they trained the foundation model to not only produce text or images, but actually to take action on the keyboard and mouse. Mm-hmm. So it can control your computer, the keyboard and mouse. Yeah.
Exactly.
And it seems to do rather well. So what you do is you basically prompt it and say, I want to, they give it a number of examples. They gave it an example like, I want to have some kind of sightseeing examples in the weekend when my friends comes to San Diego. And then, you leave over the computer to the AI and it starts to open up the web browser. It can open the browser itself. It types in a Google search saying sightseeing events in San Diego. It reads the result. It takes screenshots all the time, so it sees what's happening on the screen, and it can control the keyboard and mouse. And then it gets some output. It's summarizing them and finds these are the top events, and then it opens up the Outlook calendar or Google Calendar, and it enters in a new item in the weekend. Here is the sightseeing event you should do. And it can then, start using the applications and the interface that you must otherwise use on the computer, and do that in a much more general way. And then there are much more examples, like creating code, and you can ask it to create a web page, and open VS Code, the coding environment, and it starts to run stuff there, and it can see when errors happen, it can fix the error, and then start doing it.
This is mind-blowing when you start combining what this means.
Yeah. And then, of course, this is the first version. Actually, Apple did something similar. Apple has always been late on AI and machine learning, but they have Apple Intelligence, which especially is their version of machine learning. But they actually had something called, what was it? Screen awareness or something. So it actually watch what you do on the screen. And this is actually related to your field as well, Anders, which is they want to be privacy conserving. So the data from the mobile phone don't leave and goes into the Apple cloud. So by just watching the phone and what's happening on the screen, they can recommend stuff by understanding what's happening. So this is something similar, but I think in a much more general sense and much more profound. It's basically saying that if you want to take actions, instead of training a single action on, I want to do a web search, or I want to use a calculator to do some kind of math operation, it now goes a step back and say, I can do meta operations. I can do whatever application I want.
And now, in the next sense, now you can create your agents where you define different agents. You have a meta model, you have an SDK for this, and within this sense you can then...
And it can even go to other LLMs. I saw some example that said, it actually opened up ChatGPT. So the LLM was opening ChatGPT to get an answer to how to do that, and it used the answer from the LLM to take further actions. This is actually very profound, I would say.
It sounds cool, but very scary also.
Yeah, but it shows the trajectory of what we are researching. When we say AGI, sometimes it feels like it's somewhere out there. But what we are talking about is moving up the abstraction layer of problems we are solving and the sequencing steps we are taking. And the fundamental topic of agency, we're moving away from only prompting to actually actuating things, doing things, acting, right?
Yeah,
and agency here is the major topic, I think.
Yeah,
I would give away agency.
A language model trained on my emails that can reply to all my emails as if I did it, so I can do research instead.
Yes. Exactly, that's a fantastic bot.
And even take actions to research to answer the email properly.
But you are not so far away from an avatar thinking here. This is avatar land. Very soon we are.
And even though this is first version, it works surprisingly well. That's the
crazy stuff, isn't it?
And I hate to be a doomer here, but I have to give like a doomer example of this. This is actually very similar to the Terminator movie. In the Terminator movie, you had Skynet, some kind of a defense system against nuclear attacks. And the problem with the defense system was that humans were too slow to see when actually someone is launching an attack. It takes too long time, and it's too much data for humans to actually to look into. So they said, okay, let's take the humans out of the equation. Let's give the full power to the Skynet computer to much quicker react to something happening.
You're a Skynet
nerd. And then it's
the plot.
You basically push the button, and you push the button, and that time, humans are taken out of the control.
But so James Cameron, he was sort of envisioning that this agency. This is exactly his argument.
Now we just prompt the Claude, computer use feature, but if you were to just remove the human and let it prompt itself, it's actually a Skynet moment in some way. Right?
We heard that there was an article that most of the geniuses in the world, they actually tend to look at the history and the literature and the SF and etc. And then they romanticize this. And so when they're creating products, they're actually creating products that were their imaginary.
But yes, this is the whole sci-fi romance and the tech bro. The tech combination,
bro.
The tech bro. So they all have this romanticized sci-fi topic. I've seen articles like this on Elon Musk, and if you there are many examples of that their utopia is not a real utopia. It's their adventures reading as 12-year-olds into Asimov or into. I've seen that comment.
Yeah.
Tech bros.
Tech bros.
Yeah. Cool stuff, I think, but also scary.
But I went on the rampage. I've been on a rant or a journey where I think agency and agentic AI matters, and we even talked about it in the opening season. And we had Luca here, and I happened to hear a conversation or a keynote from him where he talked agentic in the spring. And I've been doing a lot of research on this in terms of what does that mean in terms of how enterprises organize when we are elevating the machine to co-workers. We get a principal agent relation with our machine. That we are not organized for that. I can tell you that. So I think pat myself on the back. I'm on the money here. This is profound stuff that will have huge impact in how we organize work, how we organize business, ultimately. That's why to follow agentic, what do we mean with agency? What do we mean with agentic workflows? What are we talking about here? What are we actually doing? Super important to understand where it leads to.
Yeah, I attended a small, it was a small WASP DDLS conference in Gothenburg. And then what was one presentation where one researcher had developed some kind of automatic researcher that along the same lines that
like an avatar.
It proposed what should be the next experiments to do, and then it did experiments and collected the data.
The AI scientist.
AI scientist. And then from that it draws some conclusion to do what are the next experiments, and so it could work itself.
I mean, this is also, the levels that OpenAI produce. They had basically 5 levels, and what they started with was the conversational AI, the chatbots that we have today. They're moving to reasoning. That's basically where we are today. We're starting to see it with O1. Next one is autonomous, which is basically agency. And then it comes innovating AI, they call it. And this is where they start to be more creative, perhaps more the AI scientist kind of approach. And finally, the level 5 is what they call the organizational AI, saying that an AI is much more intelligent than a single human and reaching the scale of a single organization like Google or whatnot in terms of capabilities.
Yeah, and I think this is one of the better definition ladders of what we are understanding when we say general intelligence or general. Because there's been different definitions on how do we define AGI, and there's another one floating around which has DeepMind has one. But this one is very practical in terms of what the research problem is, or what they are focusing on solving. Yeah. So it's interesting as hell.
Cool. Scary but cool, I guess.
Yeah.
Okay, getting back to the theme of the podcast as well. Let's get to perhaps a bit more future-looking. What's going to happen coming years. What do you see privacy can be, of course, super important, and we're going to have ways of doing that, and federated learning is one part of that equation. But what would you say the main obstacles in coming years will be when it comes to, let's call it privacy-preserving machine learning? I guess it's very related to the application you just made, and perhaps is basically what you just mentioned. But if you try to be a bit more speculative and say, this is actually what I think is important to have privacy-preserving machine learning in the future, what would that be?
You mean the most important application, or?
If we think, I think more like challenges in terms of being able to preserve human privacy or data privacy for humans while still having AI technology growing, as we were just spoken about in so many ways, but without having to have integrity kind of problems going forward. It can be anything from being inspired from music that is generated by humans, that LLMs and foundation models can now easily produce themselves, or it can be more integrity kind of related questions, or data security in terms of how can companies keep their trade secrets. What do you think the challenges will be going forward?
Well, I think one challenge is, let's say that you manage to train a good model using federated learning, and that you want to make this into a clinical product. Then I've never done this process myself, how to go from research to a clinical product. But you need to convince the FDA or the corresponding European organization that your model works as you want. And then they may say, like, okay, but show us the data you used for training this model. And if that means that you need to bring all the data in one place, then you have lost the point of federated learning.
Right.
Because if they require to see all the data you used,
that's a very good point.
So then you've lost the whole point of.
So you're arguing as well also that one of the biggest challenges and how will this progress, or how ubiquitous will federated machine learning become, has a lot to do with how regulation is.
Yeah, I think there's a big difference if you're talking about research or if you're talking about using it for real products.
Yeah,
but I think it's interesting also. I think you switched the whole question there, which is actually very good.
That's a really interesting.
It's not perhaps how we can preserve privacy, but also how we can gain the possibilities that AI can provide, and for medical, clinical field, that can be immense benefits of this, but that can be prohibited or challenged by the by privacy concerns potentially. So if you flip the question, how do we find the balance between still preserving privacy while still reaping the benefits, so to speak, of AI possibilities in the medical fields?
And being transparent and being explainable and all this. Because you have the balancing act now that we have XAI, explainable AI, coming in as a different force into this that maybe pushes a completely different agenda.
Yeah, I think that one key point is to be able to quantify leakage or memorization. Because if you want to have discussions with legal experts or hospitals, they want some hard numbers on will it leak 5% or 50%, or because otherwise you cannot even have a discussion. I mean, then they may just say no, just to be sure that it will not leak. They will just take the easy solution, which is to say no to everything.
But maybe, can I try another angle, future outlook? Because I remember first time I met Andreas, we talked about this and they started scale out. This is about 2019-20. And to me, intuitively, I posed myself the question in 2020, and I want you to now answer what you think about this now. I posed myself the question, what is the future outlook for going distributed, federated versus monolithic? And my fundamental understanding from the energy ecosystem is that, damn it, the whole ecosystem is by design distributed. It's a network, it's an ecosystem. And here now we have techniques that are more centralized, and we're trying to do that. So my understanding of this topic, without going into any of the problems, any of the details, is like, use the trajectory. Are we moving from federated techniques or distributed techniques being a fringe activity to being much more normal? So what is the future outlook here? Are we gradually getting more and more into the distributed, or will this continue to be sort of a fringe activity because it's hard and all that? Because I had a view on this in 2020, but I'm not so sure. It's not so easy. When I know more now, it's so many topics.
I think it may depend a lot on each field.
Yeah.
But I don't see federated learning as the only solution. I see it as one of the solutions.
Yes.
And then like synthetic images is another solution.
Yeah.
So I think it will be one of the solutions you can use, and it has certain benefits and certain drawbacks. And then synthetic images have certain benefits and drawbacks. So I think it will increase the usage, but I think there are more legal obstacles than technical obstacles.
If you phrase a question like this, it has to be some balance in some way. If you have the quantifiable kind of obligation saying it's 1% or 5% leakage, if you require 0%, we have to shut everything down and we can never, use any AI at all. Would you say today, are we on the side of having too high requirements in terms of privacy or too low requirements to reap the benefits? So to speak?
If you consider what this Swedish authority on privacy, I think they are too strict because you have to balance the risk to the benefits. And I think for some reason, I think that Sweden is in general too strict, like in the interpretation of GDPR compared to other countries. Yeah. And I don't know why that is the case.
Why that happened?
Maybe just that Swedish people are more nervous or more they're afraid of doing something wrong.
But it's interesting how you get so risk averse. So like we had guests here who flipped the whole argument. How many lives should die because of this, right? Is that ethical to allow lives to get people killed because of privacy concerns? How do you balance this? What is the right balance here? That we are omitting to do the right thing.
I think you should look more at the benefits.
Yes,
and one simple way of avoiding GDPR is to only use data from people who have died. because the GDPR doesn't apply if you have passed away.
Oh, interesting.
So if you may still need ethics approval, but I think GDPR doesn't apply when you have passed away. So then we could potentially use their data.
Maybe. But I guess a question could be, what is the opportunity cost of not using AI, as you mentioned?
Exactly.
And we had some guests on that before, and we can see that if we use AI in this way, and whatever way that is, then perhaps we can serve 50% more patients or something that could get helped and not have serious damages or even die. And if we at the same time then use AI, we may have some problems with privacy and perhaps some issues happening from that, and then you have to basically balance what is the cost of privacy versus cost of healthcare, right?
Yeah, I read, I think recently they announced that, I don't remember how many, but that people in Sweden had died because patients have died because there was not enough clinical staff to treat them.
And if you can double the productivity, we call it that, of nurses and doctors that we have in the medical care, we could serve so many more patients.
But we know we have a huge shortage in staff within 10 years. We know this from pension.
So I think
we know we are getting into some really troublesome waters in Sweden.
We have to use AI to save time in medicine. But then I think the key question is how much privacy are we willing to sacrifice to...
Yeah.
Because to me this also becomes not about... I don't like when you make this a bipolar or very simplistic question, because it's a nuanced question. And there can be many examples where you can apply a framework where you treat outliers in a certain way. There are many different ways to sort of to balance this. So the whole black and white conversation. I have so many examples there. I work at Vattenfall. We need to have the highest security because we have nuclear. Okay, so this application now, it needs to follow these security standards. And then I asked a simple question. How many people are using that particular application in relation to that I need to put that a security standard on my whole cloud? 26 people. Okay, so you mean I'm going to put a technology security standard of 10,000 people because I have 26 outliers? Why don't I fix this in a much better way for the 26 persons? So what I'm trying to get to is the argument that why do we need to be bipolar? Why don't we need to make it black and white? Why can't we be nuanced? Why can't we find what is the real, okay, this is a security risk problem. Could you define that, please? Could you go 5 levels down, and then we can tackle each thing, and then I think we can get much further. But this is a much more sophisticated conversation, much more expert conversation, but it's not impossible, in my opinion. It's simply that as long as we stay on this high fly level, we get nowhere.
Yeah.
Do you agree with that rant? Because that's my rant on this.
I think as I mentioned, this interpretation by the EME was too strict, and that they basically, as I understand it, they see any machine learning model as personal information.
This is black and white, then, right?
Yeah.
It's a black and white argument.
I think they are too strict because that's the easy solution to say no to everything.
It's kind of a lawyer approach. You should never ask a lawyer if you're allowed to do something.
No.
You should just ask a lawyer, how can I make this work?
Exactly. I learned this the good way.
Tell them afterwards.
Yes.
No. I perfected this a couple of times in large enterprise, where it's how you approach the legal department, how you phrase the question. Is like, because they cannot say yes, so you need to come with a case, and you need to understand what do I need to fix, and if I fix all that, what do I need to fix now, and then in the end they run out of so it's completely doable, but you cannot approach them in the wrong way, because then the whole thing breaks down, in my opinion.
But I think also we shouldn't be. I think we can have technical solutions to privacy and data safety concerns. And I think the country and the company that works the most in this field will be very, very successful. So there are a lot of research questions that we should phrase, and I think what you're doing, Anders, here to improve that, to build more knowledge in a scientific way, to say that this is actually how we can have data safety while still achieving AI performance, which is what Federated Learning is doing to some extent. I think that's super important, and the more we can do work in this field to keep reaping the benefits of AI while still preserving privacy and data safety aspects, that's super valuable investments.
And used to add to that, as you said, getting some hard numbers behind these theories, good or bad, means you can baseline. Then you can start the real conversation. Yeah. So sometimes the whole conversation lacks a baseline. Yeah. So I think those kind of questions are super valid in a broader sense in Sweden.
Yeah, I can mention another project we are working on, where we are exporting image data from 21 hospital regions. I mean, we have the same laws everywhere in Sweden, but so for every hospital region where we want to export data, you need like an approval, and that sort of requires someone to sign off. But so the challenge here is that even if we have the same laws everywhere in Sweden, each hospital region can interpret the laws in different ways.
Of course.
So you don't need to have one discussion, you need to discuss with 20 lawyers. And they may have different opinions and interpretations.
And maturity and competences and all this.
So to have one discussion is one thing, but to have 20 discussions.
But this is how it works. But maybe this is also a part of the fix or the solution, how this can become more efficient. Maybe this is where we need the AI agent, right?
It is, right? I mean,
or the Swedish government or the parliament needs to say, this is, we decide this for every hospital.
Yeah. Exactly. So it's the ambiguity and it's the lack of clarity that opens up for, I mean, like this is like when you do a strategy and you leave the tactical empty. You know, you can build systems in 10 different ways. Everybody knows that. So you can have endless arguments on governance or architecture.
Yeah, so I think I don't remember the exact name of the agency, but there was a governmental agency that contacted me 1 or 2 years ago. And they wanted to do some kind of investigation on what is like the future of using, or how can we train deep models in medicine. And if I remember correctly, their conclusion was the exact opposite of Federated Learning. They wanted a centralized server where you put all the data.
Interesting.
And where everyone can log in instead.
And they solved the topic of sharing data in a completely different way.
Yeah.
I'm biting my tongue here. But yeah, super interesting. I mean, we should be open-minded, though, in finding the best way to do whatever we can. Do you have any concerns with the AI Act, by the way? I think, also what we mentioned before, for GDPR, for example, it's not really the regulation itself or the intention that is a problem, is the uncertainty around it that cause, companies and people to be afraid of it. And if we solve that, we can actually have a very, good future with safety in mind. And to me, I'm a bit scared that the AI Act will have the same, effects that GDPR, that it's the uncertainty of how to really comply with it that will cause more problem than a real attention. So what's your thinking about the AI Act?
Yeah, my first guess is that it will hinder a lot of research and implementation. Because
the medical field will be almost all of them in the high risk kind of category, right?
Have you done that? The work you're doing now. If you look at your portfolio, how many of them are category 9? Or what categories will be your main categories that you will apply in? Or
I cannot really say.
Because it's hard to judge, right?
Yeah.
It's really hard to judge.
But in medicine, there's another regulation called MDR.
Okay.
For medical devices, that's also really tough to interpret. And
so it's the interpretation and the opaqueness of all this that hinders people. And that, we had the examples with GDPR. I think we have the classical Claes Olsson case or someone else. I think we can mention them by now. It's preskriberat.
Yeah, maybe not.
Maybe. fuck it, I did it. Someone basically say, we're going to stop this because we don't even know what this is leading to. This is just headache. Let's take away. We shut down our recommender engine because, it's too much headache. And this is what lead. I mean, like if you don't have a big
real consequence.
There's real consequences that, you know what, it's so many uncertainties as it is. We might just spend our money somewhere else.
I mean, I hope someone do consider the opportunity cost. In Clas Ohlson or some retailer, having not the recommender system in place and lacking on the win-win solution for both the customer and the company. Otherwise, perhaps can be handled. But for the medical field, we are speaking about human lives, and I think this is something that we shouldn't really take or trifle with. I mean, it will have big impact if we don't do it properly. And we need to consider the opportunity cost of this properly. Sad topic here.
No, it's an important topic, and but it's solution oriented.
I heard like 1 week ago that it's a bit strange, but if you buy a clinically approved AI product to use in hospital, if you just use it out of the box, you don't have to apply for any permission, or you can just use it. But if you want to make some small tests, like how well does it work on our patients, then you have to write a long application to Läkemedelsverket and explain what you will do. And I mean, so you actually want to do the right thing, which is to see how well does this work here in our hospital. But then you're punished that you have to write a long application instead of just using it out of the box.
And just to make it clear, of course, we all believe that regulation needs to be in place. We should have regulation, especially in the medical field, so no one thinks otherwise. But it's important to have the right regulation and the right way to be compliant with it.
But
I think no one is arguing for no regulation.
No.
And I think the important thing to get across as a message is the pet peeve that we've been pushing hard for several years is that we need to worry more about the how and the practicalities of this. And I even said, like, what, that's a competitive advantage to Sweden. Klarna has this value proposition, smooth payment. So I was picturing smooth AI Act for Sweden, to have the test.
I think that's a positive thing.
It is a competitive advantage.
The one that actually gets
the one that gets this right.
Yeah, that gets it right as a country or as a company, they will stand out.
Yeah,
they will have a huge advantage.
So if you can create a self-service, we even had Petra Dalunde here at Drive. So she's working with the test and evaluation facility, the TEF, around the AI Act to set up a self-service for medium-sized business in Sweden. I think it's a brilliant initiative, and I'm like, okay, let's use pour money on that and make that into the most coolest agentic app you can think of, right?
Yeah.
That would be such
the ROI on that,
the ROI, the no-brainer, the no regrets. So what should Vinnova invest in? The AI Act agent, in the TEF
with the sandbox or the testing environment,
all this
helps companies to comply with
and making RISE and the or a university make money out of this instead of the lawyers and the consultants.
Time is flying away. We are up to 2 hours already, so perhaps we should start rounding up a bit. And Anders, I would like to ask you a very philosophical question. So imagine, do you believe that AGI will happen, and approximately why, if so?
It's very hard to say, but maybe in 10, 20 years.
So assuming that it has happened, and try to think, how will the world look like when it happens? Then we can think of a spectrum. You can think about two extremes. One extreme is the Terminators of the world, where we have computer use, and we will have a computer that is considering humans to be a threat, and they try to kill us all. And it's the Matrix Terminators kind of scenario. It's a horrible dystopian kind of future. And the other extreme is perhaps the utopian one, where you think that we have AI that's solved cancer, for example, that you mentioned, or it has solved the climate change and the energy needs that we have, and basically all the goods and services in the world are free of charge, and we live in a world of abundance, as some people call it. Where do you think potentially we will end up? More towards the dystopian or more towards the utopian? What's your thinking?
Well, I try to be optimistic, but yeah. I think it can really. I mean, I'm sort of a Star Trek nerd. So I'm thinking in the best case it can sort of help us to make starships and go to other planets, and
they live without monetary value, right? So they don't have like salaries in that same sense as we do.
Yeah, what is the income approach? What is the in Star Trek? It's unclear, right?
They don't have money in that way.
Does Captain Kirk make money, or is he working for fun?
They just do what they think is interesting, like doing research. Or
they live in a. The Star Trek is a society of abundance in that sense, right?
It is.
I think. I mean, I think something like that would be the best case scenario, but. And I know that Jeffrey Hinton, he left Google just to talk about the dangers.
Yes.
So I think the main challenge is that we can go from stupid computers to very smart computers in maybe a few days. Like if this automatic, what did you call it?
Computer use.
Yeah. If that takes off, it can take off like in 1 day or 1 hour. And then you cannot stop it if it's so fast that it...
But this is the fast takeoff scenario you're referring to now, that Tegmark has made
Yeah,
examples
I mean, that's the challenge, that I guess it's really hard to know how fast will it happen.
Exactly.
How fast will it contact other computers that also become self-aware.
Exactly.
And perhaps you don't even need to be that intelligent to have this kind of fast takeoff in a bad way scenario happening. It can actually be a stupid AI that can spread very quickly, like a virus. A virus is not intelligent, but it can be extremely damaging.
We said sometimes, several times, we are more afraid of the narrow AI gone rogue than the general AI that is actually.
Yeah, but maybe we should think like this: can an AI do more stupid things than Donald Trump?
No.
That's an awesome ending statement. And,
you know what? I'm all for the AI.
Oh, well, with the election coming up, this will be a very
that's a timely joke.
Yeah.
I love it.
Very cool. I hope you can stay on for the after work discussion when we turn off the cameras. But thank you so much, Anders Eklund, for coming here. It's been a true pleasure to have you here.
So cool stuff you're working on.
Thank you.
Thank you.